Welcome. The next concept that we are going to discuss is moment generating function. As I said in one of the previous lectures, generally nth moment is denoted as expectation of x bar n, which is either integral x bar n f of x dx or summation x bar n p of x. Okay, so this moments are going to play some important role. They are going to play some important role in probability theory. Sometimes we may not be interested in calculating the actual probability, but rather interested in calculating the moments such as mean, variance, standard deviation, and these things. Okay, so uh, as the name suggests, moment generating function is a function through which we can generate the moments without the help of probability. Okay, the situations where we are not too much interested in probability but rather interested in moments, we can make use of this moment generating function. It is denoted as mx of t. So it means moment generating function of the random variable x, which is the function of t, which is nothing but expectation of e to the power tx. Okay, how does it land in? If it is a discrete random variable, it is summation e to the power txi and probability of xi. Okay, where I runs from whatever the limits is. So this is for the case of discrete random variable. If it is a continuous random variable, it is integral e to the power tx f of x dx, and we will integrate it over the corresponding limits of be it summation or integration. Once we complete this process, at last we will get some function of t. Okay, that is what we denote as mx of t, and your expectation of x bar n is the nth derivative of this mx of t at t equals 0. Okay, in most of the cases we will evaluate the moments about origin, which means about mean. Okay, these are some higher concepts. Anyway, let us, as of now, let us remember that expectation of x bar n is the nth derivative of this moment generating function at t equals 0. Suppose if you need mu, that is mean, that is derivative of m at 0. Okay, if you need a variance, it is second derivative at 0 minus mu square. Okay, now let us see a problem. Here we are asked to obtain the moment generating function of a random variable whose probability density function is given to us, that is x in this 0 to 1 interval, 2 minus x in the interval 1 to 2. Okay, now to find the moment generating function, what are we doing? It is expectation of e to the power tx. So it is defined from, if you see, it is actually from minus infinity to infinity. Here from minus infinity to 0, it is 0. Okay, and from 0 to 1, this function takes the value x, so e power tx multiplied with x dx. From 1 to 2, it is e power tx multiplied with 2 minus x dx, plus from 2 to infinity, it is e to the power tx product with 0 dx. Even here it is e to the power tx product with 0, that is why it is 0, it is 0. So all we need to do is to integrate these two integrals. Now you can apply integration by parts or a Bernoulli formula to integrate all these things, and finally here you are going to substitute the limits only for x, right? So finally you would end up with some function in t. Now that you have the moment generating function of this function.